Welcome to our backyard. This is the Backyard Philosophy Podcast. We are two friends having a discussion after everyone else has passed out or gone to bed. Grab a drink and listen as we discuss everything from automation, space exploration, and why the meaning of life is 42.
Imagine a demon that was spawned into the earth by a man that drove people crazy with just the idea of this very demon. Imagine for over a century has been wreaking havoc, and scientists all over the world have been working together to find ways to overcome this demon. A demon breaking the laws of physics, or in this case, thermodynamics. You get Maxwell's demon, a demon of entropy. But before I tell you of this scientific demon that plagues physicists, engineers, and scientists alike, Nick, how are you and what are you drinking?
I am ready, and I'm drinking some Busch Light.
I love the optimism. I'm joining you with some tin cup whiskey, and I'm happy to be back in my familiar world of thermodynamics. Yes, we're back to physics, pulled an old switcheroo with the demon plaguing humanity thing, but it has been a demon plaguing people's mind. But before we get into what Maxwell demon is, we need some base knowledge. Let's start with entropy. Entropy is a measurable physical property in the degree of randomness and disorder. What the hell does that mean? It means energy lost in a system. Energy cannot be created or destroyed, so let's just say it's energy displaced in a system. Here's an example of entropy. Imagine you're playing a game of billiards. All the billiard balls are racked up and ready to be broken up. The racked balls are organized, not moving. They have low entropy. They're organized. But as the cue ball hits the billiards, they spread out across the table, making it more disordered, more chaotic. Now, the billiards have high entropy. Entropy is highly tied into temperature, both hot and cold. Another easy example is as ice melts into water, the atoms of the water molecules now have more freedom to move around. They are not frozen in place. See what I did there? Ice, frozen. No, never mind. The more freedom that they have to move around, the higher the entropy. They have more possibilities of random arrangement. So think of a drop of water, all those H2O molecules inside that drop. Now try to figure out how they're organized, because they are floating around. You have tons of different possibilities. And if it's frozen, you have less possibilities because they're stationary, they're solid. More room means more chaos. And vice versa. If I take water and put it in the freezer and it becomes a solid, like I said, it has less movement, so therefore it has less entropy. But a very key distinction that I want to make, in order to turn water into ice, I had to put work into the system to lower the entropy. Entropy on its own never decreases. Entropy is always increasing. Like, if I put energy to make a scrambled egg, I can't unscramble the egg. But if I mix water and whiskey together, I can put in work and energy to separate them. All of this is related with entropy. Now, take my examples with a grain of salt. I'm just trying to use them to convey an analogy. I'm trying to make it as simple as possible. All of this leads us to the second law of thermodynamics. Like I said, entropy is highly correlated with temperature. So, it is very tied into thermodynamic laws. The second law of thermodynamics states that heat energy cannot be transferred from a body at a lower temperature to a body at a higher temperature without additional energy. What that means in layman terms, if I mix hot water and cold water together, they will reach an equilibrium, a middle ground. The hot water will never take the remaining hotness from the cold water to make itself hotter, nor will the cold water take whatever coldness the hot water has to make itself colder. To put it in simple terms, all things in thermodynamic systems, like many things in nature, want to find a calm and easy to maintain state. Along with all that thermodynamic system, you have wasted heat. No system is perfect. There's no perpetual motion. The work you put in will never be the exact work you get out. The more waste, the higher the entropy. All that heat loss in the system, it causes disorder and chaos, not just in the local system, but throughout the universe. Other atoms hitting one another, which cause a chain reaction, almost like a butterfly effect. It could be changing the room's temperature, exciting molecules to move around that you don't tend to. Think friction. If I'm pushing, say, a heavy box, the box on the ground will cause friction to the ground, causing heat. There's wasted energy in form of heat, and the more heat I generate, because it's harder friction, the more gas molecules get excited and pushed around on the universe, and that plunges into other gas molecules and cause a chain reaction. This was the norm, this was the law, no question. Until a James Clerk Maxwell, in 1967, had an idea that would release a demon into the scientific world, a demon that would challenge the laws of nature itself. This demon, Maxwell's demon, would be a thought experiment. The thought experiment goes like this. Imagine two boxes, both exactly identical, same in every way, both filled with gas molecules in them. The same temperature, the same amount of gas, same size, all the same in exactly every single possible imagination you can have. These two boxes would be connected by a single door, a door in which a demon would control. Now this demon, through its magical powers, could see which molecules in each box were traveling faster or slower. For if you have molecules in a box, they bump into each other, causing them to speed up, which makes them hotter, or if they hit multiple molecules, they might slow down, making them colder. Increased energy makes things hotter, decreased energy makes things colder. The demon, through his magical powers, could tell which had more energy. The demon would open the door, moving every hot molecule to one side and every cold to the other. By opening the door at the right molecule at the right time, over time, the demon would have moved every hot, fast molecule to one side and every cold molecule to the other. The action of this would, in theory, decrease the entropy of the gases in the box without applying any work. It would break the second law of thermodynamics, which, if you're not a loser nerd like me, is mind-blowing. Laws in physics are not like country's laws. The laws of physics cannot be broken. Never bending, never wavering, always true. It's why there are so few laws in physics, and it's so hard to become one. But Maxwell and his pet demon in this thought experiment broke it. The demon removed disorder from the universe. This idea, this analogy, plagued scientists, physicists, and engineers for over 100 years, some spending decades on working to conquer the demon. Many starting and just simply saying it's impossible with no reasoning and just move on. Many gave up trying to process this paradox Maxwell created. A few scientists would be major crusaders. They would be the priests trying to exorcise this demon. The first of the crusaders would be Claude Shannon. Shannon would show that information itself contains entropy, a major step forward. This would happen in 1924, if I remember correctly. The next would be Rolf Landauer, a German-American, in 1961, showing that deleting information would release work, thus releasing heat, meaning even erasing an idea, information, heat is released into the universe. About 20 years later, a true eureka moment happened in 1962 when a physicist, Charles Bennett, put both Lauder's and Shannon's ideas together. He put them together to try to conquer Maxwell's demon, to expel it to where it once belonged. Charles came to the conclusion that the demon operating the door at its very base level is information. Knowing which molecule was what, knowing their state, their trajectory. The demon wasn't magical. The demon was just a processing machine. The demon knew what molecule were hot and cold and would no longer care about them. So once the demon got the molecule to the other side it wanted, it forgot about it. The demon was storing and erasing information. And like Shannon and Loniger discovered, those two actions of memory and deletion create entropy. They create disorder in the universe. The demon, trying to create order by lowering entropy, would in fact, through its process, increase entropy. But that's all well and said. That's just a theory. And theories, well, they need to be put to the test. In 2007, at the University of Edinburgh, an experimentation was done. They replaced the demon with a light-powered gate to simulate it. And in 2010, a modified version of Maxwell's demon by using the demon's information habit to move a beat uphill. Then in 2016, at Oxford, Maxwell's demon, instead of gas, using molecules left to right, they reused light to make sure the process still mattered for both physical matter and light. All the scientists, all the experimentations found the same answer. This demon, this ideal creature that plagued scientists' mind for over 100 years, was nothing more than a fairy tale. The demon had no true power. All the experiments found that entropy increased, never decreased, no matter the situation. The modifications or the simulations, it did not matter. The second law of thermodynamics' good name was redeemed. It only took 115-ish years and a dozen scientists to defeat this demon, but you may think to yourself, why do I care? How does this affect me? Fair question. The ideas thought up, tested, and experimented, they can all be used to help create more efficient systems. Better refrigeration to help stop world hunger. More advanced microchips for faster computing. Better power plants to keep the lights on without destroying the planet. Every inch adds up. In Maxwell Demon, it shows and helps society learn and apply to bring dreams and the future into reality. That's Maxwell's Demon, a creature that only existed in your mind, but help push many to learn and create, to innovate and think. Perhaps this demon isn't a demon at all, just an angel in disguise. And I hope I explained Maxwell's Demon well enough for you, Nick, because this was a cluster and fuck trying to figure out how to put it in really simple terms.
I think you did a good job. I actually got that. I think. As well as I'm going to.
Famous last words. Yeah. Entropy, I implore you all to investigate more into. It is the chaos that enters the world, and it's something as common as energy, but it's a word not very used and not very implied, but it's everywhere around us and it's fundamental. And yeah, I hope I did Maxwell good, and I hope I did all the scientists who investigate and think about this good, and I hope to those listening and you, Nick, I did a decent job of trying to explain this physics phenomenon.
Well, I think you did a pretty good job.
I'll take it. Thank you all for listening.
Thanks for listening to the Backyard Philosophy Podcast. We rarely finish a podcast without missing a point we wanted to bring up, so let us know what we forgot. And if you have a topic you want us to talk about, let us know at Backyard Philosophy on Instagram and Backyard Philosophy Podcast